Alright, so in this video, let's take a look at the diode, which is the first device that we're going to take a look at in the semiconductor family. It says, when a junction is formed between an N-type and a P-type semiconductor material, the resulting device is called a diode. This component offers an extremely low resistance to current flow in one direction and an extremely high resistance to current flow in the other. These characteristics allows the diode to be used in applications that require a circuit to behave differently according to the direction of current flowing in it. An ideal diode would pass an infinite current in one direction and no current at all in the other direction. Alright, so this is a symbol of the diode. One side, the P side, or the P-type material is the anode, and the N-type material is a cathode. Alright, so in the middle we have the depletion region. Let's continue reading. It says, if the P-type semiconductor material is made positive relative to the N-type material by an amount greater than its forward threshold voltage, about 0.6 volts if the material is silicon and 0.2 volts if the material is germanium, the diode will freely pass current. If on the other hand the P-type material is made negative relative to the N-type material, virtually no current will flow unless the applied voltage exceeds the maximum breakdown voltage that the device can withstand. Note that the normal diode will be destroyed if the reverse breakdown voltage is exceeded. Alright, so let's take a look at these two circuits here. In this circuit, the diode, in this circuit here, the diode is in forward bias. Notice that the P-type side of the anode is connected to the positive side of the battery, and the N-type, the cathode, is connected to the negative side of the battery. This is what is known as forward bias. When the forward threshold voltage for a silicon diode, which is 0.6 volts, is applied, the diode will enter in forward bias and it would allow current to flow in one direction. If on the other hand the diode is in reverse bias, meaning that the negative side of the battery is applied to the anode and the positive side of the battery is applied to the cathode, then notice the size of the depletion region. The gap between the P-type material and the N-type material, it's wide, so this prevents current to flow in one direction. This is the characteristic, the curve characteristic for the diode. Notice that a silicon diode will start conducting approximately 0.6 volts, and a germanium diode will start conducting somewhere around 0.2, 0.3 volts. So now let's take a look at LEDs, or light emitting diodes, and how to calculate the current limiting resistor for an LED. It says a light emitting diode, LEDs, can be used as a general purpose indicator and compared with conventional filament lamps operate from significantly smaller voltage and currents. LEDs are also very much more reliable than filament lamps. Most LEDs will provide a reasonable level of light output when a forward current between 5 milliamps and 20 milliamp is applied. Right here, in order to limit the forward current of an LED to an appropriate value, it is usually necessary to include a fixed resistor in series with an LED indicator, as shown in this figure. the value of the resistor might be calculated from using this formula. This is a very important formula. The value of the resistor is equals to the voltage of the power supply minus the diode forward bias voltage divided by the current. So this is a circuit. Notice that this is the LED and this is the current limiting resistor, and current is going to flow in that direction. Alright, so let's do a couple of exercises. The first exercise says, this figure shows the characteristics of a diode. What type of material is used in this diode? Give a reasonable answer. Alright, so the type of material being used here is silicon. Why silicon? Because notice that the forward voltage of the silicon diode is somewhere around 0.6 volts. Okay, forward voltage for the silicon diode 0.6 volts. Alright, so let's do this exercise. An LED is used to be used to indicate the presence of a 5 volt DC supply. If the LED has a nominal forward voltage of 2 volts and is rated at a current of 12 milliamps, determine the value of the series resistor required. Right, so we are asked to calculate the value of this resistor. Notice that the forward conductive voltage of the diode, in this case this is an LED, is 2 volts, and we have a power supply of 5 volts. Alright, so, and the diode is rated for a current of 12 milliamps. So based on that, let's calculate the current limiting resistor. So R is equals to voltage of the power supply minus the diode forward voltage over the current. Alright, so let's plug in the numbers. That will be 5 minus 2 over 0.012. So let's go ahead and bring the calculator. So that's 5 minus 2, that's 3 divided 0.012, and we need a 250 ohms resistor in order to limit the current flowing in the circuit to 12 milliamps. Alright, so that is the video. Thanks for watching, and I'll see you in the next video.